All right. So we're at section 8.5. We're going to spend 2 days on this section, so I decided to split the video up just to make it shorter, and um, I think it's the right thing to do. Oh, here we go. We'll see how you feel. But the title of this section is Add and Subtract Rational Expressions. Um, and complex fraction is the first vocab word. Sorry, just all that. That's actually part of the second part of the video, but we'll fill it in anyway. So a complex fraction is a fraction that contains a fraction in its numerator or denominator. Again, this will be part of day 2, but I can give you an example. You could have something, that looks like this, just with numbers. And we'll deal, of course, because we are in algebra class, with variables, but this is a 3. So a fraction within a fraction is called a complex fraction. Let's put that aside for right now. Let's talk about adding, and also, same would be for subtracting with like denominators. So where your denominator is the same. And this is, you should be very happy. Any problem that comes across with like denominators, we're very happy. And this has a lot to do, similar, all your rules that you know for fractions. So you basically, the adding fractions, you just add the numerator and you leave the denominator the same. So here you get 9 plus 2 divided by the common denominator of 6 over x. And here, nice example, we get 11 sixths. You really should check though. Imagine if this had come out to, 15 6x. You could reduce your final answer. So you always, again, from our lesson today of simplifying, every time you circle your final answer, you really should say, is this in simplified form? So what happens now is we need to start thinking about when we add or subtract and with unlike denominators. So we need to come up with a least common denominator, which, LCD, which is also called the least common multiple of the denominators. So you rewrite each expression using the LCD, then add and subtract. Very similar to fractions. So nothing, really not learning anything new, just having to deal with, like this kind of problem now. So you're used to like 1/3 plus 1/5. We're now dealing with rational expressions. So first thing here is to kind of get a look at the denominators and decide what the common denominator is. Hopefully you're eyeballing this and saying, I could factor this second denominator. And so when we factor that denominator, you get a 2x times x plus 2. And then notice there's a common factor in, 4 is really 2 squared and x squared. I'm not sure we all need to do this, but hopefully you are seeing that the least common denominator is 4x squared times the quantity x plus 2. And again, the worst thing you could do is to maybe scale this up. So you could come up with a common denominator, like if you just looked at these, you looked at the 4x squared and multiplied it times this other denominator. You could get 8x to the third, but that's not the least common denominator. So hopefully you see that the 4x squared and the 2x share, common factors. So that's a big part of this unit, is to come up with that least common denominator. Again, that factoring move is going to be so important. So now here we go. How do we add these two rational expressions? We need a common denominator. So ends up we have to multiply, and I wish they had used parentheses here. So this whole, you have to multiply this whole first expression by 1, and you should be shaking your head going, wait, that's not 1, that's 2. Sorry, that's x plus 2 over x plus 2, but the value of that is 1, so we're allowed to do that. And same for the second expression, we need to multiply this by 2x over 2x, which is also the value of 1. Sorry, just interrupted. I'm back. And so when we multiply, we need to multiply top and bottom. Again, it shouldn't be a surprise that we multiply the denominator with the x plus 2. We should get our least common denominator. But it's really important that we multiply the numerators correctly and get 5x plus 10. And then the numerator on the second expression would be 2x squared plus 2x. And now we get to add finally, right? So when we add, we should there is no other x squared term, so we just leave it 2x squared. We do have a common 5x with another x term 2x, which would get you the total of 7x plus 10. and you should take a look, and it doesn't happen often, but maybe there's factors, and one of the factors is x plus 2. So you should really, in the end, look to simplify. Be super careful, right? The x squares do not cancel. The 2 and the 4 does not cancel. And hopefully you felt better about that in today's class. So here we go. This is a subtracting, right? Subtracting with unlike denominators. So again, looking at the two denominators, I'm hoping you're seeing that there's some factoring that can be done. And that is going to be important to figure out your least common denominator. So your least common denominator here is 3, x minus 3, x plus 3. So you kind of grab, I've got a 3, an x minus 3, but they're common, so I don't repeat it. And then I've got an x plus 3. So your least common denominator will end up being, there, I'll show you way down here. This is your final denominator that you're going for. So you need to look at the first expression and say, hey, he's missing an x plus 3. So I will multiply top and bottom again. Love the big parentheses, right? This is a common one, very unusual one. 3 over 3 should feel more comfortable from your adding and subtracting fractions. Here you should take the time now to distribute 7 into x, 7 into 3, and then check this out. I would be careful here with this subtraction because notice the 3 times x plus 4 is x plus 12, but when I subtract, this subtraction sign needs to distribute into both the 3x and the 12. So I'm actually subtracting 12. I think the book kind of was a little loose here, skip that step. But it's probably the most common mistake that I see in math is that folks will add 21 and 12. But notice this subtraction will be applied to the 12 as well. Really, really, really keep a lookout for that, right? So 7x minus 3x is 4x, and 21 minus 12 is 9. And again, you might look here just to see anything cancel and nothing factors on the numerator, so you're done. So you got 4 problems to practice. The first 2, I think everybody should look at and say, well, fantastic, right? Common denominators, not a big deal. But 3 and 4, please, we're almost done with the video. Again, take a time, factor it, see if you can't decide what the least common denominator is. And again, with this subtraction here, make sure you distribute in. So please hit pause and try the 4 problems. I say 4, but to me they're really only 2 problems. And here are the answers. So again, very straightforward here. We just ate x minus 7 with the common denominator here. It's just, here, this one's kind of nice, right? This would have been 15 over 3x. And if you circled that, well, then you forgot to simplify down, right? So you wouldn't get full credit. You do need to always simplify your answers. Here, hopefully you factored this denominator and this one and saw that your common denominator would be x plus 3, x plus 3. You'd have to have 2 x plus 3's, right? Because he has 2 of them. So, and an x minus 3. This top and bottom needs to get multiplied by x minus 3. And this guy, top and bottom, needs to be multiplied by x plus 3. So your final answer should come out to x squared plus 4x plus 15. Hopefully you got it. And then 4, probably the hardest of this section so far, is with the subtraction here. Hopefully you factored this second denominator, saw the common denominator as 4x squared times 2x minus 3, and then you'd have to multiply this guy top and bottom by x, and this guy top and bottom by 2x minus 3. Again, we need to practice this. It's going to be a big deal. That's why we're taking 2 days. I will see you Monday in class. Thank you.